I am Vilma D'Souza from the Department of Mathematics, AG Institute of Engineering and Technology, Mangalore. Today I am going to deal with the topics Newton-Raphson Method and Regula Falsi Method of 18MAT21 of VTU prescribed syllabus. Now you have two types of equations basically known as algebraic and transcendental equations. The equation f of x equal to 0 is said to be algebraic if it is a polynomial in x. That is, if f of x contains only a polynomial in x, then the equation f of x equal to 0 is called algebraic equation. Whereas on the other hand, if f of x contains some other functions other than polynomial, you have trigonometric such as sine, cos, tan and so on, log functions, exponential function, then the equation f of x equal to 0 is called a transcendental equation. For example, I have given one example each here. The first one you can observe, it contains x and its powers. So it is a polynomial. F of x is a polynomial. So f of x equal to 0 is called algebraic equation. Whereas in the second equation you can see f of x contains exponential function as well as some trigonometric function tan x. So it is called transcendental. It is not entirely a polynomial in x. It contains exponential function as well as trigonometric function. So it is called a transcendental function. Now you have two types. In this video we are going to study two methods for finding the solution of algebraic and transcendental equation. The first method here is method of false position, or also known as Regula Falsi method. So this equation is used to find a solution for the equation f of x equal to 0. As I told you, it is either algebraic equation or transcendental equation. So in this method, what you do is, see, I have shown it here in the figure. XY coordinate system, you have a curve y is equal to f of x. I have drawn in blue color. Y is equal to f of x. So in this Regula Falsi method or false position method, what you do is you consider 2 points. Here x0, y0, and here x1, y1. You consider 2 points x0, x1 such that y0 and y1 or f of x0 and f of x1 are of opposite signs. That is, if f of x0 is positive, f of x1 must be negative, or vice versa. So here how to find the solution is, we assume that f of x0 is positive, f of x1 is negative. That means f of x0 and f of x1 are of opposite signs. So in such case, what happens is, when they are of opposite signs, you can observe x0, f of x0 positive, f of x1 is negative. So definitely the root lies between x0 and x1, somewhere here, right? So we shall name it as x2. The root of f of x equal to 0 lies between x0 and x1. Now the equation of the chord AB, equation of the chord joining AB, A and B. A is a point x0, y0, B is the point x1, y1, x0, y0 and x1, y1. You know the equation of the line joining 2 points x0, y0 and x1, y1 is given by y minus y0 divided by y1 minus y0 is equal to x minus x0 divided by x1 minus x0. So similar method we are using here. Y minus f of x0 is equal to f of x1 minus f of x0 divided by x1 minus x0 into x minus x0. This is obtained by rearranging the terms. Now when y equal to 0, that is on the x-axis, we get x equal to x2. So substitute y is equal to 0. put y equal to 0 and simplify this. You will get x2 is x0 minus x1 minus x0 divided by f of x1 minus f of x0 into f of x0. This derivation is actually not there in your syllabus. Just for your understanding I am giving you. Now this is the first approximation. Similarly, if f of x0 and f of x2 are opposite in sign, then the second approximation x3 is got by replacing x1 by x2 in the formula. Wherever you have x1, you are replacing it by x2. If f of x1 and f of x2 are opposite signs, you are replacing x0 by x1. So this procedure is continued till the root is found with the desired accuracy. That is, two successive values xn and xn plus 1 are nearly equal. So hope you understood the method. The first approximation is, first you are finding two values x0 and x1 such that f of x0 and f of x1 are of opposite signs. Okay, then by using the formula, you are using this formula, x2 is equal to x0 minus x1 minus x0 by f of x1 minus f of x0 into f of x0 to find the first approximation x2. Then you find whether f of x2 is greater than 0 or less than 0. If f of x2 is greater than 0, wherever you have x0 in this formula, you replace it by x2. If f of x2 is less than 0, here you have f of x1 is less than 0. So instead of x1, you write x2 in this formula to get x3. So you go on calculating x3, x4, x5 till two successive approximations are equal. Okay, now we shall consider a problem. The question is here, find a real root of x cube minus 2x minus 5 is equal to 0. Correct to 3 decimal places between 2 and 3. So here it is given in the question itself, the root lies between 2 and 3. Okay, so you are taking x0 is 2, x0 is 2 and x1 is 3. Since it is given in the question itself, you need not find what is x0, what is x1. Directly from the question you can take x0 is 2, x1 is 3. So f of x is given to you. Find what is f of x0, what is f of x1. F of x0, f of x is given, x0 is 2. So f of x0 is 2 cube minus 2 into 2 minus 5. Right? 2 cube minus 2 into 2 minus 5. That gives you minus 1. Find f of x1, that is f of 3. 3 cube minus 2 into 3 minus 5. That gives you 16. So you can observe in this problem, f of x0 is minus 1, that is less than 0. F of x1 is 16, that is greater than 0. So f of x0 and f of x1 are of opposite signs. Now to calculate the first approximation x2, you have the formula x2 is equal to x0 minus x1 minus x0 by f of x1 minus f of x0 into f of x0. You can substitute x0 is 2 minus x1 is 3 minus x0, that is 2, divided by f of x1, you have it as 16, f of x0 you have minus 1, so minus of minus 1 becomes plus 1, into f of x0. F of x0 again minus 1. Simplify this by using your calculator. So I will explain you again. X0 is 2 minus x1 is 3 minus x0 is 2 divided by f of x1, that is 16, minus f of x0, minus of minus 1, that gives you plus 1, into f of x0, that is again minus 1. So simplify this entire term using calculator. You will get it as 2.0588. It's enough if you write the answer correct to 4 decimal places. Once you have calculated x2, you find what is f of x2. You have what is f here, right? F of x is x cube minus 2x minus 5 is equal to 0. So calculate what is f of x2. F of x2. What is your f of x2? F of x2 is f of 2.0588. Wherever you have x in the equation f of x equal to 0, put x as 2.0588. You will get minus 0.3908. So now you got f of x1. You can go back and check. F of x1 is less than 0, negative. Sorry, f of x0 is negative. F of x1 is positive, and here you are again getting f of x2 is also negative. So the root lies between, previously the root was between 2 and 3, 2 was, but f of 2 was negative. So now instead of 2 you are using 2.0588. Okay, 2.0588 and 3. So now you can take x0 as 2.0588 and x1 as 3. Calculate what is f of x0, what is f of x1. Okay, f of x0, that is by substituting x is equal to 2.0588. You already calculated here. You have f of x1 which is already calculated. Use the same formula. X2 is equal to x0 minus x1 minus x0 divided by f of x1 minus f of x0 into f of x0. Okay, or else you can take this as x2 itself, this as x2 itself. In the formula you can write x3 is equal to, replace this x0 wherever you have by x2. Okay, so go on doing this. You will get the next approximation as 2.0915. The very next is 2.0934, then 2.0941, then you will get 2.0943. Okay, so finally you can, by observing these two values, you can say that they are almost equal up to third decimal. So you can conclude your answer as 2.094 correct to 3 decimal places. Hope you understood the problem. So I have done here x3. Since f of x2 is also positive, you are replacing x0 by x2. Okay, f of x3 comes as negative. F of x3 comes as negative. So x2 has to be replaced by x3 now. Again you calculate x4. x4 comes as 2.0897. So calculate what is okay. I have given the answer here. I have given the answer x5 is equal to, you can refer the previous slide, x5 is equal to 2.0915 and so on. Finally you are concluding the answer. Okay, so we shall move on to the next problem. Find the root of the equation x e power x is equal to cos x by Regula Falsi method, correct to 3 decimal places. Okay, so here you can observe it is not an algebraic equation, it is a transcendental equation and also contains trigonometric functions. Wherever the equation contains trigonometric functions, you need to set your calculator to radian mode. Otherwise, all the calculation you do with the degree mode will be wrong. Okay, so remember this, you are setting your calculator to radian mode wherever you have trigonometric functions in your equation f of x equal to 0. Now what is your f of x here? So first you set your remember to set your calculator to radian mode, then we shall proceed to find the solution. What is f of x now? F of x is equal to x e power x minus cos x or cos x minus x e power x. Now here x0 x1 is not given. You need to find 2 points such that f of x0 and f of x1 are of opposite signs. So basically in such case we start with 0. Now what is f of 0? F of 0 cos 0 is 1. 1 minus this is 0. Right? 0 into e power 0. What is e power 0? E power 0 is always 1. But it is 0 into 1 gives you 0. So cos 0 is 1. Next f of 1. Cos 1 minus e. The value of e, exponential function, you can find by using the calculator. Okay, so f of 1 you will get it as minus 2.17798. So you can observe here f of 0 is 1, that is greater than 0. F of 1 is minus of 2.17798, that is less than 0. So you can say the root lies between 0 and 1, right? You are taking x0 as 0, x1 as 1. Already you have calculated what is f of x0, that is f of 0, that is 1, and what is f of x1, that is f of 1 is minus 2.17798. Okay, now you calculate what is x2. You have the Regula Falsi formula with you. Write down the Regula Falsi formula. Okay, you have x0 as 1, x0 as 0, x1 as 1. Substitute x0 0 minus x1, that is 1 minus 0. 1 minus 0 is 1. F of x1 minus f of x0, I simplified and written here, into f of x0. F of x0 is again 1. Simplify this by using your calculator. 0.31467. Okay, so this is your x2, the first approximation. Find what is f of x2. What is f of x2? F of x you have cos x minus x e power x. So wherever you have x, replace it by x2. What is your x2? Your x2 is 0.31467. So f of x2. Calculate. Hope your calculator is in radian mode. Calculate f of x2, 0.51987. So it is again positive, greater than 0. So you have seen f of x0 was positive. You can go back and check. F of x0 is positive and f of x1 is negative. Right? F of x0 is positive, f of x1 is negative. Now you are getting f of x2 as positive. So instead of x0 we are using, x2. You can observe it here. Instead of x naught, you are using x2, that is your x naught will be now x2 0.31467. So the root lies between 0.31467 and 1. So continue the procedure. Go on calculating the next approximation. X naught, now here x naught is x2, that is 0.31467, minus x1 is 1 minus x naught, that is x2 0.31467, divided by f of x1, you have calculated here, minus f of x naught into f of x naught. So simplify this entire term using calculator. Be careful with the minus sign here. Okay, you have minus here, and also minus here. You will get 0.44673. 0.44673. Okay. So we shall move further. Once you have calculated the approximation, calculate f of x3. What is f of x3? Wherever you have x in the equation f of x, you replace it by x3 value. That is 0.44673. You can observe, you can verify this. 0.20356, and it is again positive. It is again positive. So you can say the root lies between 0.44673 and 1. Since f of x naught was positive, now you are getting f of x3 is positive. You are replacing x naught by x3. The root lies between 0.44673. So wherever you have x naught, you substitute it as 0.44673. x3 you use. Okay. You can observe this calculation. x4 you will get it as 0.49402. Right. So go on calculating this. You can fix your, since it is asked three decimal places, you can fix your calculator to 3 decimal places and write down the solution in terms of 3 decimal places also. It is enough. When you go on calculating, you will get here x8 0.517 and here 0.518 if you round it off to 3 decimal places. So you can observe they are almost equal. So you can write the answer as 0.518, correct to, this is not 4, correct to 3 decimal places. Okay, next we shall move on to the next method. I will give you more problems on that later. We shall move on to the next method, as I told you, that is Newton-Raphson method. Another method of solving an equation of the type f of x equal to 0. So this method is used to find the solution of the algebraic or transcendental equation when the derivative of f of x is a simple expression. So both the methods we are using to find the solution of f of x equal to 0. So this method is especially used when f of x is a simple expression. So we shall see what the formula is. Let a is equal to x naught. Then you are finding the first approximation x1 by using the formula x1 is equal to x naught minus f of x naught by f dash of x naught. This is your first approximation. So what is the second approximation? x2 is equal to, instead of x naught you are using x1 now. x1 minus f of x1 by f dash of x1. This is your second approximation. Next to calculate x3, x3 will be x2 minus f of x2 by f dash of x2. So go on calculating x4, x5. In general you can say xk plus 1 is equal to xk minus f of xk by f dash of xk. So this is the iterative formula for Newton-Raphson method. Okay, iterative formula because you are going on finding the values x0, x1, x2, x3, etc. so that xn and xn plus 1 are almost equal. Okay, we shall consider one problem here. The question is, using Newton-Raphson method, find the real root of x log x to the base 10 is equal to 1.2 correct to 4 decimal places. X log x to the base 10 is equal to 1.2 correct to 4 decimal places. Okay, take the function as f of x is equal to x log x to the base 10 minus 1.2. Find what is f of 1. F of 1, that is, put x is equal to 1. You will get minus 1.2. F of 2, that is 2 log 2 to the base 10 minus 1.2. That is minus 0.59794. You can check out this. F of 3, 3 log 3 to the base 10 minus 1.2 gives you f of 3. So you can observe here f of 2 and f of 3 are of opposite signs. So the root lies between 2 and 3. Now what is your f of x? Since you need to find f dash of x, you have to simplify what is f of x. F of x is x log x to the base 10 minus 1.2. Now you are writing this log x to the base 10 as log x by log 10. You know log m to the base n is log m by log n. So this is x into log x by log 10 minus 1.2. Right? So that implies, what is f dash of x? What is f dash of x? The denominator is a constant log 10 to the base e. X into differentiation of log x comes as 1 by x. So x into 1 by x, that becomes 1 plus log x into differentiation of x, that is 1. So that is simply log x divided by, it is a constant, log 10 to the base e. Okay. So that is equal to 1 by log 10 to the base e or log e to the base 10 plus log x by log 10, that is log x to the base 10. Okay. Hope you understood this. 1 by log 10, that is log 1 by log 10 to the base e is log e to the base 10. Log x by log 10, that is log x to the base 10. So now what is your Newton's formula? Xk plus 1 is xk minus f of xk by f dash of xk. So xk minus, what is f of xk? Xk log xk to the base 10 minus 1.2 divided by log e to the base 10 plus log xk to the base 10. Okay, this is the iterative formula. Now we shall go on calculating the values. Okay, now how to find this x naught? How to find this x naught? We have seen f of x naught, f of 2 and f of 3 are of opposite signs, right? So when you say they are of opposite signs, definitely a root lies between 2 and 3. So you can choose x naught as 2, x naught as 3, or even you can choose x naught as 2.5 in between this. So in this problem I have chosen x naught as 2.5. So calculate x1. You have the formula with you. X1. What is x1? x naught minus x naught into log x naught minus 1.2 divided by log e to the base 10 plus log x naught to the base 10. K is equal to 0. You are putting k is equal to 0. So substitute for x naught. X1 is equal to 2.5 minus 2.5 log 2.5 to the base 10 minus 1.2 divided by log e to the base 10 plus log 2.5 to the base 10. So calculate. Here you observe it is log 2.5 to the base 10, not to the base e, to the base 10. So when you simplify, you will get 2.7465. So like in Regula Falsi method, you need not check whether f of x1 is greater than 0 or less than 0. You go to the next one, x2. x2 will be x1 minus f of x1 by f dash of x1. Okay, you will get it as 2.7406. Calculate x3. It is 2.7406. You can use the same formula. x3 will be 2.7406 minus 2.7406 into log of 2.7406 minus 1.2 divided by log e to the base 10 plus log of 2.7406 to the base 10, and you will get it as 2.7406. Since the two approximations are the same, x2 and x3, we can conclude that x is equal to 2.7406 is the root of the equation. Okay, we shall consider one more problem wherein you are finding the root of x e power x is equal to 2 correct to 3 decimal places using Newton-Raphson method. The question is here, f of x equal to x e power x minus 2. As before, you are finding 2 points x0 and x1 such that f of x0 and f of x1 are of opposite signs. Okay, so you are starting with 0. F of 0 comes as negative, minus 2. You can verify this. F of 1, 0.7182, that comes as positive. F of 0 is negative, f of 1 is positive. If f of 1 also comes as negative, you can go to f of 2 and check out. But here f of 1 is positive itself. So these are of opposite signs. So you can conclude the root lies between f of 0 and f of 1. Okay, here I have taken x0 as 1 only. You can take x0 as 0 or x0 as 1, or you can even take the midpoint of this, that is 0.5 as x0. You have f of x with you. Calculate f dash of x. F dash of x is x into e power x plus e power x. X into differentiation of e power x, that is e power x, plus e power x into differentiation of x, that is 1, and this term differentiation becomes 0. This differentiation is 0. So f dash of x is x plus 1 into e power x. Fine. Okay. Now you use the formula. What is your Newton's-Raphson formula? xk plus 1 is equal to xk minus f of xk by f dash of xk. xk plus 1 is xk minus f of xk by f dash of xk. What is f of xk? xk into e power xk minus 2. We are substituting here xk e power xk minus 2 divided by xk plus 1 into e power xk. This is f dash of xk. Okay, now you put k equal to 0, you will get what is x1. x1 is x0 minus x0 into e power x0 minus 2 divided by x0 plus 1 into e power x0. x0 is your 1. So 1 minus 1 into e power 1. E power 1 is e itself minus 2 divided by 2, that is 1 plus 1 e power 1. This e is nothing but e to the power 1. You can find using calculator. So simplify the entire term, you will get the value of x1. Okay, now go to x2. What is x2? K is equal to 1. x2 is x1 minus x1 into e power x1 minus 2 divided by x1 plus 1 into e power x1. x1 value you have here, substitute 0.8678 minus 0.8678 into e to the power 0.8678 minus 2 divided by 0.8678 plus 1, that is 1.8678 into e to the power 0.8678 is equal to 0.8527. Okay, similarly you calculate x3. What is x3? x2 minus x2 e power x2 minus 2 divided by x2 plus 1 into e power x2. Wherever you have xk, substitute it as x2. The value which just now you got, x2. Calculate, you will get 0.8526. So you can observe here, x2 is 0.8527, x3 is 0.8526. So you have to get the answer correct to 3 decimal. So up to 3 decimal they are equal. So you can conclude your answer. Therefore x is equal to 0.8526 or 0.853 is the required root correct to 3 decimals. Okay, here you have one more simple problem. 3x is equal to cos x plus 1. Solve this by using Newton-Raphson method. Correct to 4 decimal places. It's already given here. X, the solution is near 0.6. The solution is near 0.6 and x is in radians. So make sure you will set your calculator to radian mode before you do the calculation. Okay, now what is f of x? F of x is 3x minus cos x minus 1. You have to write in such a way that the equation becomes f of x equal to 0. So the terms on the right hand side can be brought to the left hand side. 3x minus cos x minus 1. That is your f of x. And f dash of x, differentiate this. Differentiation of 3x is 3 minus differentiation of cos x is minus sin x. So it becomes plus sin x. So f dash of x is 3 plus sin x. xk plus 1 is xk minus f of xk by f dash of xk. So xk plus 1 is equal to xk minus f of xk, 3xk minus cos xk minus 1. This is not cos xk minus 1, cos xk minus 1 divided by 3 plus sin xk. So remember here this is cos xk minus 1. Okay. Now here already x0 is given. So you need not find 2 points wherein the root lies within those 2 points, within that interval. So take this 0.6 as your x naught, this 0.6 as your x naught. X naught is 0.6. What is x1? X naught minus 3 into x naught minus cos x naught minus 1 divided by 3 plus sin x naught. Right? X naught is 0.6. So 0.6 minus 3 into 0.6 minus cos 0.6 minus 1 divided by 3 plus sin of 0.6. So hope your calculator is in radian mode. Right? So calculate this using your calculator. You will get it as 0.6071. So go to the next iteration. x2 will be x1 minus 3x1 minus cos x1 minus 1 divided by 3 plus sin x1. Your x1 is 0.6071. So x2 is 0.6071 minus 3 into 0.6071 minus cos 0.6071 minus 1 divided by 3 plus sin of 0.6071. So you can calculate this again using calculator. You can observe, you will get the answer as 0.6071. So here you can observe, go back to x1. x1 is 0.6071. So x1 and x2 itself are equal. So you need not go to the next iteration. This is a simple problem here. You need not go to the next iteration. You will get x1 and x2 are equal. So you can conclude your answer. The desired root is 0.6071. Okay. If suppose this 0.6 was not given, you can calculate what is f of 0, what is f of 1. You will get f of 0 and f of 1 are of opposite signs. So you can take, you could have taken x naught as 0.5. Okay. We'll move to the next problem. Obtain the iterative formula for finding the square root of n and hence find root of 41. So this is a different kind of problem which are the applications of Newton-Raphson method. So in such kind of problem, what you do is you take x is equal to root n. X is equal to root n. So in order to get rid of this root n, you can square, you will get x square is equal to 1 or x square minus n is equal to 0. Okay. So now this is your f of x. F of x is equal to x square minus n. So what is f dash of x? F dash of x is 2x. F of x is x square minus n. F dash of x is 2x. So write down the formula for Newton-Raphson method. xk plus 1 is equal to xk minus f of xk by f dash of xk. That is xk minus f of xk. xk square minus n divided by f dash of xk, that is 2xk. Okay, simplify xk minus xk square minus 2 by 2xk, that is xk by 2. Fine. Minus of minus becomes plus, plus n by 2xk, n by 2xk. So this is xk minus xk by 2, xk minus xk by 2, you will get it as xk by 2 plus n by 2 xk. So that 1 by 2 if you take out, 1 by 2 into xk plus n by xk. So this is the iterative formula for finding the square root of a number n. Xk plus 1 is half into xk plus n by xk. Okay, this is the iterative formula for finding the square root of a number n. So now using this formula, you are finding root of 41. That is, your n must be 41 now. To find root of 41, how do you find root of 41? Root of 41. Observe that root 36 is less than root 41. You know root 36 is 6. Right? Next number is root 49, that is 7. It is greater than root 41. So you take here root 36, that is 6. So you can choose x naught as 6. Choose x naught as 6. So use the formula. You have the formula here in the last slide. What is the formula? Xk plus 1 is equal to half into xk plus n by xk. So what is your x1? Half into x naught plus n by x naught. Half into x naught plus n by x naught. So half into 6 plus 41 by 6. Simplify this. Simplify this to get 6.4166. Okay, next you calculate x2. x2 is half into x1 plus 41 by x1. x1 you have the value here. x1 plus 41 by x1. That gives you 6.4031. Similarly, x3. x3 is half into x2 plus 41 by x2. That is 6.4031. You can verify this calculation. Verify this calculation. x3 comes as 6.4031. You can observe x2 is 6.4031. x3 is also 6.4031. So x2 and x3 are almost equal. Not almost equal. They are exactly equal here. So you can stop your iterative procedure. Conclude your answer as 6.4031. Root of 41 as 6.4031. Okay, you have another problem here wherein again an application of Newton-Raphson method, wherein you find an iterative formula for the pth root of n and hence find cube root of 10 correct to 3 decimals. Okay, so here what is your x? Pth root of n to the power 1 by 3, 1 by p. So x to the power p is equal to n, or x to the power p minus n is equal to 0. So what you do here is you take f of x as x to the power p minus n. F dash of x is p into x power p minus 1. Right? Use the Newton-Raphson formula. X to the power k plus 1 is equal to xk minus xk to the power p minus n divided by p into xk to the power p minus 1. So this is the iterative formula for finding pth root of n. You need not simplify here. So the question is hence find 10 to the power 1 by 3. So already you know 8 to the power 1 by 3 is less than 10 to the power 1 by 3. Cube root of 8. What is cube root of 8? Is 2. So you can take x naught as 2. X naught as 2 and p as 3. Right? Cube pth root, that is cubic root of P is 3, N is 10. So go on finding x1, x2, x3. You can observe here x2 and x3 are almost equal. So you can stop the procedure here and conclude your answer. 10 to the power 1 by 3 is 2.1544.